just reached if it have to. Okay, let's spend another 15 to 20 minutes. We just spoke about verification and testing in the previous slide. So let's see what is that in more detail. What are the major differences between verification and testing? Both are very different. And please understand this. This is a very important concept you should remember throughout your life. Same in software, hardware systems, wherever you go. So verification is the pre-silicon what we do, and testing or validation is what we do post-silicon. So let's not go to validation. Let's see testing. So verification verifies the correctness of the design. It checks the behavior of the design. This verification of the manufactured hardware. Notice testing. Remember, look at the red keywords, right? So verification checks the correctness of the design. The lab 1 and 2, you're writing the test bench for a data path and control path. That is verification, right? So what we do later in the course in the lab is testing. So understand, okay? So the verification is done by running simulations, or it can be a hardware emulation or a formal methods. Hardware emulation is nothing but using FPGAs, right? And formal methods is a very recent method, still evolving. So simulation is that's what you're doing in the lab 1, right? Testing has a 2 parts: test generation and test application. And you have to generate the test patterns. Then you want to generate the test patterns. You have to apply the test patterns at DUT. Look for a pass or a fail signature, right? So test has a 2 parts. Please take notes, important topic. So verification is performed before the tape out or prior to manufacturing. It's performed prior to the tape out. And test is performed on every manufactured device, right? So tape out is only once. So verification is done only once. And takes 70% of the tape out time, right? From start to tape out, you see it takes 100% of time, 100 months. So 70 months goes in just in verification. Right? For a thumb rule, right? It's not, may not change from chip to chip application, not just guidelines or thumb rule. So better the testing has to be on every single device you manufacture. Let's say I perform 100 billion smartphones or 100 billion some healthcare product. You have to test all the 100 billion devices or the chips in all the different conditions: process, voltage, temperature, stress conditions, and everything, right? So that's what is the thing. It's extremely important, testing. Verification also is extremely important. So we are learning testing in this semester. Next semester is verification. Ideally, it should have been reversed. Whatever academics have done, let's respect that. The decision, the Senate knows better what is good for students. Let's do that. So the verification is responsible for quality of the design. I told we cannot tape out the chip until the verification manager or director signs off. So extremely important for the quality of the design. So testing is important for the quality of the devices. So I want you to think, what is a design? What is a device? Please pause the video. Okay. I hope you all understood what is a design and device. If you have doubts, please ask in the classroom. What is important? We're continuing the importance of testing. We'll see what is the yield and what is the reject rate. Very important parameters. So let's spend some time. Yield is the definition, number of acceptable parts by total number of parts fabricated. Right? So how many parts? I'll give a crude example. Please don't take me wrong. This is what coming to my mind. I'm talking. So to give an example, let's say what is the world population today? 100 billion. I don't have any idea. Just assume 100 billion or 100,000 billion, 100 billion. Let's assume world population. So that many human beings are there, or living beings are there. Let's say, right? How many people have a proper health condition without any disability or differently abled? What do you call, right? So look at the percentage, right? Percentage of people with all the body parts normal divided by total number of living beings in the universe or the world, right? So very similarly, number of acceptable parts, right? Total number of parts fabricated. What do you mean by acceptable parts? Which is basically the parts which pass all your test patterns. All your tests identify, underline, write down your notes with the test which pass all the test patterns. It's called the number of acceptable parts. So that you take the ratio, that's called yield. What is the yield loss? So typically you should get 100% yield. Let's say you get only 97% yield, then 3% is yield loss. So again, coming back to original example, we said number of differently able people, right? Divided by total number of living creatures in the world. So that is the yield loss, right? You can read the definition whatever time you have. So random defects are very less, most of the structured defects, right? So variations happen because of, I told in the last slide, because of the fluctuations in the process. What is the process? We discussed in the previous class, right? What is the process of cooking? We discussed about it, right? Process of manufacturing a PCB, process of manufacturing a chip, called by etching, lithography, packaging, whatever, right? So you would be learning that in your coursework, right? So we can discuss offline if you're interested. There are fluctuations in the process. Like cooking, there are fluctuations. What if you add a little bit more salt or a little bit more spice? For one of the spice, forget about what you call tikka or mirchi in Hindi, right? If you put that little bit more, any spices, put little more or less, the quality changes, right? Put salt a little bit more or less, put add little bit of dal or less dal, or if you cook a non-veg food, you add little bit more bone or less bone, paneer, anything like that, right? So there are process fluctuations. You make a roti, you make it different shape. Let's say your grandmother makes, somebody with 50 years of cooking experience, they make rotis. All rotis will have same shape, same structural shape, same size. Is it not? So that comes with age and perfection. Similarly, in the new technology, today we are talking about 2 nanometer and 3 nanometer, right? There will be a yield will be very, very less because of process fluctuation. You go to 28 nanometer technology or a 19 nanometer technology, or India makes 180 nanometer technology in Chandigarh. It's under Ministry of Electronics department, right? So that has very good yield. 28 nanometer has a very good yield. You can get 99.99. Depends on your volume, application, die size, wafer size, and everything, right? So that is the main reason. Process fluctuation is the main reason for yield loss. If cooking also same thing, right? Process. But human being process we don't control. Nature controls. You are differently able. Everyone has. I'm also differently able. I accept that. I know what is my ability. What different ability I have, good or bad, right? Yeah, I know. But weakness you don't expose it. But if you look at some people like autistic kids, I have autistic kids in my family, right? They are visible weakness. You have invisible weakness, which all of us have. So all of us are differently able, right? So let's support autistic kids and differently abled human beings, and any living creatures, a dog or a cat, whatever it is, right? So what is testing? That is a very important concept. Listen carefully. Faulty device appears to be a good part passing the test, right? I'll read again. I'll pause for a moment. Okay. Hope you understood that. Or a good device which fails the test appear as a faulty. So it's a listening and practice self-learning exercise. I'm not going to talk. I'll pause for a minute. Pause the video. Think what does these two statements mean. If you have questions, you can ask. Okay, let's assume. Okay, so yield loss can be because of your lack of design for testability, lack of DFT. You didn't do a good design, or you didn't go a good design for testability. You didn't add correct logic for observability, controllability, scan chains, memory best, whatever. We are going to talk throughout the course. Compression, we're going to talk throughout the course, right? If you don't do your test properly, design for test properly. For that, I said you should know design, should know how to verify, then we'll go design for test. Unfortunately, the Senate plans that way. We'll have to work, right? Academics for the best for us. It's called design for testability. Is improper design for testability causes yield loss. So faulty devices are returned back to manufacturer. They go through FMA. We spoke about FMA in the last video. Failure mode analysis. Write down the notes. We'll talk later. They'll do an analysis. They'll find out which part of the die or the wafer, which part of the die has a defect. They'll do X-ray, some electron beam testing. They'll find out, open the chip, find out which part of the die has a problem. But there's something called failure mode analysis. It's a detailed concept. There's an interest and time. We'll talk about it. So what is the reject rate? This again you are learning for self-learning. Just a theoretical definition. I'll pause the video here. Self-learning. Okay. Hope you understand. If there are any doubts, please ask questions in the classroom. So ppm, that's the important thing. What is a ppm? Any guess? Pause for a moment. Okay, it's parts per million. Got it correct? Hug yourself or pat on your back. Rather pat on your friend. You cannot pat on your back. You can try. So pat yourself, hug yourself. Parts per million, ppm. And I'm going to talk about dppm, rest of the course. Defects per parts per million. Pause the video, think what is parts per million and defects per parts per million. Think, pause. Okay, this is what I call meaningful pauses. You have to understand what it is, right? So reject rate of 500 ppm may be considered as acceptable in some applications, while 100 ppm or lower represents high quality in certain application. It is upon your customer need and end product needs. What is your volume? What is your cost? What is your profit margin? It's business decisions basically, right? There is something called Six Sigma manufacturing. So you can do a Google search or ask ChatGPT appropriate question, understand what is Sigma, pause the video, do Google search. Okay, hope you understood what is Six Sigma. So you should be near zero defects. Is it possible to have near zero defect? Go back to the first example. You told number of defect weaknesses. To err is human. There's a proverb, right? We all make mistakes. Can you show me one human being who has never made a mistake in their life? Even God makes mistakes. That's why He created me. I'm just joking, guys. Take it easy. Right? Everyone makes mistakes. You make a mistake, I make a mistake, but don't repeat it second time. Right? So that's valuable. Lessons learned, what we call in corporate. Right? There should be a process for that. In fact, it should be for Six Sigma standard in manufacturing, should have less than 3 dppm or less. So if you have make a million part, only three parts can go wrong. Very strict process. That gives a very high yield. Your quality goes high, your profit goes high, your customer is happy because customer is God. You are my customer. You are my best friend. Right? Students are my customers. I treat them as gods because customer is a king and God. Why is testing important? 3-4 minutes, right? They will not bore you. This is a self-learning slide. I'm going to pause. You have to pause the video, learn yourself, pause for 5 minutes, learn, introspect, visualize, understand the concept, apply the concept, frame examples. You could do it part of assignment if you want, but I'm not enforcing. So for your introspection, pause the video. Okay, this is another important slide. We spoke about 2 slides before. What is a good IC and faulty IC? We spoke about good human and bad human. Can you tell who is good, who is bad? Am I good? Am I bad? No, I'm in the middle. Sometimes I become good. I'll be nice to you. Sometimes I elect you to get my task done. I'll be bad man because I want you to be successful in the career. I'll come with a stick behind you sometimes. Sometimes I'll wear a friend hat. Sometimes wear a faculty hat. Sometimes wear a demon hat. I have different hats. Based on situation, I wear appropriate hat. I wish I don't wear other hats. So that's up to you. You behave as a friend. I'll be a friend always. I'll be your best friend. Okay. So this is a good IC means true pass. I'm a true friend to you. That means I'm a good human being, right? I'm a human being first, then my religion, caste, creed, everything comes. Go to industry, equality. We have gender equality and everything is equal. Everyone is equal. You cannot bias and hire a person. You cannot say because you have dress code, you have different religion. You have to accept that in Qualcomm kind of companies. You're differently able person, I have to hire as well as you have the skill, right? So that is the true character, right? So that's a true pass. Faulty IC, the test is passing, but if the IC is fault, right? And let's say I'm a bad person, you conduct an aptitude test for me, I fail, right? So fault the test passed. Let's say I'm a bad person, but your aptitude I pass the aptitude test. That means there's some pass in the test. There's some fault in the test. It's what we call test escape. That has to be very less. You can correlate it with Apple. You take good Apple and bad Apple. You can apply the example. Good phones and bad phones. You understand example. Right? Similarly, the fault. The good IC, failing the test is a yield loss. What we spoke, right? Good IC should pass. It should not fail. That should be less the better. That means you higher the yield. What you want, right? These are the trade-offs. Okay, and this is what is important. The green and red are very important. Faulty ICs must fail. Listen, must fail. Right? Bad apple must be a bad apple always. You cannot sell the bad apple in the market. What will happen? I bought a product from Amazon yesterday. It was not bad, but I had to return. They told it is non-returnable item, but I told them there is some mistake either from my side or your side. Please help. Just 277 rupees, but I did that. I'm going to get a refund. Right? So I don't know it's true reject or false reject, but whatever. Let's not get there. But that's an example for you how to visualize, right? Okay, so this is self-learning again. So you have to read yourself and pause the video, go through every line. Any questions, ask in the class. Pause the video. Okay, last slide. Let's stop the class here. Take this quiz. I'll share the answer in the next class. Look at the quiz, write the answer, will be shared in the next class. Thank you very much, friends. Have a great day.